Warm greetings. Welcome for online video session. Myself Jagadish, Associate Professor, Department of Computer Science from Canara Engineering College, Bandwal, Dakshin Kannada district. Subject Software Engineering, subject code 18CS35. Till now, in third module, we have seen 3 video session. There is 3 topics related to this. One is context model and interaction model, then the structural model. In the context model, we saw how to draw the context model. Once if you get the requirement from the customer, how to create the boundaries or external environment of a requirement of the client. So in this topic, context model diagram, we saw an example, the mental health care patient management system. Then we saw about the process model of the inventory detention of the context model. Then we saw interaction model. In that interaction model, we saw how to draw the use case model and sequence model of the mental health care patient management system, and how to draw the tabular column, which will helpful for the implementation team to code the as per as customer requirement. And in the sequence diagram, we saw the actors as well as object and how to draw the sequence diagram, how it going to interaction with the object and how it responds to the actor. Then we saw the structural model. In the structural model, we saw the class diagram, then how to draw the class diagram with association, inheritance and aggregation, and how to draw the class model and what are the fields is consist. Next, coming to this, so these are the topics that we have covered in the last video session: context model, interaction model and structural model. Next, we'll see the behavioral model in this video session. Next, in another video session, we'll see the model driven engineering. So, behavioral models are of the dynamic behavior of a system as it is executing. They show what happens or what is supposed to happen when a system responds to a stimulus from its environment. So, it actually dynamic behavior of the system. So, they show what happens or what is supposed to be happens when a system responds to some events. And in the stimulus or stimuli, we have 2 types. One is data event as well as event. Data, sometimes a data arrives that has to be processed by the system, and events that happens that triggers the system processing, or events may associated with the data, but this is not always in all the cases of the requirement. Data driven modeling. Many business systems are data processing systems that are primarily driven by data. So without data, data processing is not at all happen. So data processing is driven by data. They are controlled by the data input to the system. So data will be the input to the system, and relatively little external event processing is required. Along with the data, some event that is from external it is required. We'll see some of the examples are there in the next coming slide. Okay, and data driven model shows the sequence of action involved in processing input data and generating an associated output. So data driven were the first graphical software models. First was the first software graphical model. So to understand what is going on, data flow diagram will helpful in data driven engineering. They are particularly useful during the analysis of requirements as they can be used to show end-to-end processing system. So end-to-end processing system. So one is it is generating a associated output and it is a external event processing. Next, so but you can see the activity model of insulin pump control system, how it is useful in the data driven model. So you can see the blood sugar sensor and get the sensor value, sensor data, complete sugar level, and calculate the insulin it is required to deliver to the patient, insulin requirement, calculate the pump commands. So that is as far as the requirement of the insulin calculated, it calculates the pump command whether to inject or to not, and if it is injected whether it has get the correct data as per as the requirement of the patient. The set of commands will be that is designed by the software engineers to inject to the patient body, and pump control commands and something like commands in the sense you can see it in Unix to view the date, to view the list of files. There are some commands. The same way there will be some commands. Okay, to inject the insulin to the patient. Control pumps and insulin delivered to the patient. Okay, so this is what activity diagram we have seen in the insulin pump control system. So we will see the order processing of the activity diagram for the insulin pump operation. So you can see here purchaser officer, so orders, budget and data store orders. So these are the objects. So these are the objects of the object of the insulin operations, and purchase officer fill in order, then whether it is validate, there is order what is given by the purchase officer is validate, and if the validate is okay, then according to the budget the insulin has been delivered from the data store orders. Okay, so update the amount. So then order will be that is invoice will be saved in the data source order or data store order. Then by seeing the there is a command or invoice sent from the data store order, the supplier will send the there is insulin to the purchaser officer. So this is a sequence diagram how the order process works. Okay, it's a sequence diagram how order works. Okay, so this is what the activity model of the insulin pump operation along with the sequence diagram for the order processing. So event driven modeling, there is real time system real-time system are often with minimal data processing. For example, a landline phone switching system responds to events such as receiver of hook by generating a dial tone. So by generating a dial tone. Event-driven modeling shows how a system responds to external and internal events. It is based on assumption that a system has a finite number of states, that events stimuli may cause a transition from one state to the another. So whenever any event has to be occur, there will be a finite number of states. So after after the completion of any one task, it moves to the other state. If the state which it moves, or the data has to be, or event has to be occur, if the corresponding data is not as an input for the next state, then it may go for the infinite state. So it waits till the it waits till the correct data has to be or it has to be sent from the previous state. So till that it keeps on looping in the same state, or it keep on moving to the state in which state the data has to be come for the next state. So this we are going to study in the separate chapter in the ATC in the fifth module. In the fifth semester. Okay. So state machine model. So state machine model is a behavior of the system in response to the external and internal event. So in response to the external and internal event, they show the system's response to stimuli. So are often used for modeling a real-time systems. State machine models show system states as a nodes, events as a arcs. Event as a arc between these nodes. So system states as a nodes and events as a arc between the nodes. When an event occurs, the system moves from one state to the another. If the event doesn't occur, then it keeps on moving in the same loop. So once the event occurs, the system moves from one state to the another. That's what I said in the previous slide. State starts are an integral part of the UML, that is Unified Modeling Language, and are used to represent state machine models. So you can see this is the state diagram for the microwave oven. So I said this is that is initial state, and this is end state or end of the state diagram. So you can see this is a there is semicircle eclipse. They have written the event what actually this rectangular box refers, and what event it has to perform. So when the power is off and when the power is full, it moves in this direction. When power is off, it moves in this opposite direction. So when the power is off, there is off power, there is waiting to display the time. So it displays the time here. When its power is off power, do set the power equals to 300. This is what the event has to be occur. When the power is off, set the power to 300. So 300, then make it into a full power. Okay. When the power is full power, so make it off power, that is to the 300. So this is what the event actually occur. Okay. Don't think about how it going to work in the micro oven. Just see the state diagram how it going to work. So these are the event has to be occur. So whenever this event occurs, then only the state keep on moving to the next state. Okay. So timer is been set the time, get the number exits, set the time. So time is set. So once the time is set, if the door is closed, then it is enabled. If door is open, then disable there is display waiting. So if it is not closed, door is not at all closed properly, then it won't occur any event. It keep on moving into the same state. So it displays the messages. So even though if the message is not seen, then it keep on moving in the same state. So once it is been, door is closed, it enabled, display is ready. So the set time depending upon the customer, the time has been set. So once it is enabled, start the operation. Then door start the operation, operated oven. So once door is open, once again even during the operation, then it displays that is disable the event. So once again door is to be closed and it starts the operation. Then it waits the display time till the display time, whatever the time is you have set here, it does the operation. Then after that it ends the ends the state of the oven diagram. So this is what the state diagram of the micro oven, and this is for 8 to 10 marks they will ask in the examination. So write the state diagram of micro oven. So here you have to think about the start and the end, and you can see here full power, half power. So opposite direction. So if it is half power, move to the full power. Then if it is full power, move it to the half power. So waiting, full power, half power. Then set a time. If the door is closed, enabled. If door is not closed, disabled. Okay. So once it is been closed, then it is moved to the enabled direction. So and after enable, so do the operation. So once the operation is over, then it goes to the display time. If the operation is doing the operation, if the door is open, once again we move to the display that is disabled operation, that is the door is not closed. So it's very easy diagram. Just here one is waiting, that is set the display time. So full power, off power, if it is move in the opposite direction. Then set a time. Set a time. If the door is closed, enabled. If door is not closed, disabled. Then after it is closed, move to the enabled. Then start the operation. Then after that, waiting to the display time. So then end the session. So this is what the state diagram of the micro oven. Very important question in the examination. So this is what is given in the tabular column. That is states waiting. The oven is waiting for the input. Display shows the current time. Off power. The oven power is set to 300 watts. The display shows the half power. If the oven is set to the 600 watts, the display shows the full power. Set time. Cooking time is set to the user input values. Disabled. Oven operation is disabled for safety. Interior oven light is on. Enabled. Oven operation is enabled. Interior oven light is off. Display shows the ready to cook. Operation oven in operation. Interior oven light is on. Display shows the timer countdown. On completion of cooking, the buzzer is sounded for 5 seconds. Oven light is on. Display shows cooking completely while buzzer is sounding. So this is what actually perform the operation by setting the diagram and giving this information to the software implementation team. They start working on the coding part of the requirement of the as well as customer requirement. So this is another, that is a tabular column. Off power, the user has pressed the off power button. Full power, the user has pressed the full button. Timer, pressed one of the timer buttons. Number, user has pressed a numeric key. Door open, the oven door switch is not closed. Door closed, the oven door switch is closed. Start, the user has pressed the start button. Cancel, the user has pressed the cancel button. So this is what we have seen in the states and stimuli for the micro oven. So we have micro oven operation diagram. So operation, here checking the status, turntable fault, emitter fault, that is alarm is set, and then checking hook, that is run the generator. When it is timed out, buzzer is on for 5 seconds. So door open, disabled, and waiting, cancel it. So door open, waiting. Once checking is okay, then time is set, and time out, then buzzer is sound and door opens. So then wait for the that is as per command given by the customer. So this is what there is a behavioral model of the micro oven state diagram. So by this we'll stop the video session. Next we'll move on to the model driven engineering in the next video session. If you have any doubt, you can ask, and the contents are taken from the Somerville software engineering textbook 9th edition. The contents are taken from the Somerville textbook software engineering 9th edition. If you have any doubt, you can ask in the online video session. Thank you all.